Hey, dear class, we are going to look at how to simplify radicals in this video. So you are going to have to do this frequently this semester. So it's good to go ahead and get practice at it now because it's going to show up over and over and over again. So when you are simplifying a radical, and when I say a radical, I'm just talking about a number that has a square root over top of it. When you are simplifying a radical, what you're trying to do is find a perfect square that will divide the number under the radical. So the perfect squares, I'm going to label them as PS, perfect squares, are 1, and then you go to 4, 9. All I'm doing here are just squaring the counting numbers. So 1 squared, 2 squared, 3 squared, 4 squared is 16, 5 squared is 25, and then just keep on going, just keep squaring the numbers that are the counting numbers, and they just go on forever. Just put dot 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 to indicate they keep going. Now 1 divides any number, so we don't care about 1. Okay, so really we're starting from 4 and going up from there. So I'm going to take the number 8 and I'm going to look at my list. Obviously this is bigger, so the only number that can divide it and simplify this is 4, and 4 does divide 8. So 8 divided by 4 is 2. So I can write 8, the square root of 8 is the square root of 4 times 2. Now this is a property of radicals. When you're multiplying under a radical, you can split that up into 2 radicals, square root of 4 times the square root of 2. And then the square root of 4, that's a perfect square. So we can write that instead as 2, square root of 2. And that's what they're looking for here, is 2 square root of 2 for that simplified radical. It makes the number underneath the radical as small as possible. So I'm going to put a 2, then I'm going to come down here, click the square root button, and then put a 2 under the radical, and there's my answer. Okay. Now the other one is a negative number, so just go ahead and put that negative number in there to begin with. And now let's start the process here. Same thing. We got 125, and we're looking for the numbers again, starting with 4. So there are the first 12 perfect squares excluding 1, and again, it's just 2 squared, 3 squared, 4 squared, all the way up to 12 squared. Now I stopped at 12 squared because that's bigger than the number that we're dealing with. So that would be the list that I would need. You don't need to go beyond the number with the perfect square list. Now you're looking for a number that divides this evenly, but you also want the biggest number that divides it evenly. So 125 is divisible by 25. That's going to be it, right? But I just want you to see a way that I can do this with Desmos. I can make a list. I'm just going to call it D for denominators, right? And I'm going to put a bracket, and I'm just going to put the perfect squares in there, 4, 9, right, and then all the way up to there's 11 squared. Okay, now that's my list, and now I'm going to take the 125 that's underneath there, and I'm going to divide by D. Okay, and I'm going to click the little button, and there's all the different numbers I get, and I can see this is the only one that is a whole number. So that's a 1, 2, 3, 4, the fourth one, 1, 2, 3, 4, that's the 25. So that's a way that I could do this with Desmos to kind of help me. All right. Now Desmos, this is a list command. Dividing by list creates a list. So if you understand that, you got to put a bracket in the front and a bracket at the end. But then you can use that to kind of help you to see if any of these. Now, let's just say hypothetically this had been like 127 or something like that. If I had the square root of 127, and I'm looking through here and I don't see any whole numbers, then that means that I can't simplify that. That's not going to be simplified, and I would just leave it as the square root of 127. But because we do have a perfect square factor, 125, I can work with this. So what this is telling me is I can take out that 25 here, right? And 125 is 25 times 5. Again, the 25 is what I divided by in the list, and this is what I get when I do the division. So that would be the square root of 25 times the square root of 5. Square root of 25 is 5. So this would be negative 5 times the square root of 5. Okay, just make sure you don't forget the negative. This had a negative out in front, so it's going to have a negative out in front when we simplify. So that's going to be a negative 5. Click this, all right, and then put a 5 on the inside. Now it's not always going to be the same number on the outside as the inside. That was just coincidence for this question, but that is the procedure. take your list of your perfect squares, divide the original number by all the different perfect squares, and you're looking for the biggest one that produces a whole number quotient, and that's going to be the path to simplifying it.